Okay, so here's the solution to number 13. There are two sets here. The sets are the number of people who ate shrimp and the number of people who ate steak. Now notice this, it was served to 65 people. If you go 35 plus 45, you do not get 65. That must mean some people were really hungry and ordered steak and shrimp. So I'm going to let A be the set. Let A represent the set of people who ordered shrimp, and B will be the set of people who ordered steak. So if I draw my Venn diagram, here's my nice universal set. I've got a circle here to represent all those who ate shrimp, and then I've got a circle here to represent all those who ate steak. Now, there must be some overlap. We don't know what this number is. So I'm going to let X be the people. I'm going to let X represent the people who ate steak and shrimp. So let X be okay. My pen is slowly dying, so I'm going to try my best to struggle through. So the X would go right in here. Now, I'm going to use a different color here. There are 35 people who ordered shrimp. So that's set A. So that must mean the people who only ordered shrimp must have been 35. Take away the people who ordered shrimp and steak. So minus X. Okay? So people who only ordered shrimp. So since this whole set A represents shrimp eaters, some of them ordered steak and shrimp. So if X represents those who ate steak and shrimp, then 35 X must represent those people who only ate shrimp. Similarly, over here for set B, there were 45 people who ordered steak, so 45 minus X must represent those who ordered steak only. Now, we know that the sum of these three groups must equal the total number of people who were served, 65. So what that means is, if I do 35 minus X, which is those who ordered shrimp only, plus those who ordered steak only, 45 minus X, plus those who ordered steak and shrimp, which is right in the middle, X, all together, this must equal 65. Now let's solve this equation. 35 plus 45 gives us 80. Negative X minus X, negative 2X, but plus X, that's negative X, equals 65. Subtract 80 from both sides, you'll get negative X equals negative 15. Therefore, X equals 15. So what does this tell us? This tells us that the number of people who ordered steak and shrimp must have been 15 people who ate both. The number of people who ate steak only must have been 30. The number of people who ordered shrimp only must have been 20. Because when you add up all these numbers that I just wrote, you get the number of people who were served, 65. Okay, so here's 17. So the question asks, how many ways or different combinations of questions could a student choose to answer? Now the criteria here is they're going to answer a total of 7 questions out of 12, but from the first 5, so I've from these first 5 over here, okay, from these first 5, my pen is dying, from these first 5, they can either answer 4 out of 5 or 5 out of 5, because it says each student must answer at least 4 of the first 5 questions. So the first 5 which appear over here, they can either answer 4 of these 5 or all 5. So I've made 2 cases. I'm going to look at the case where a student will answer 4 of the first 5, and then I'm going to look at a case where they will answer all 5 of the first 5. Now, so this will be, to do case 8, the student is choosing to answer 4 of the first 5. So that means from the first 5 questions, they will choose 4 to answer. But remember, they need to answer a total of 7 questions. So that means they still got 3 more questions to answer, and those 3 must be selected from the remaining 7. So we're going to multiply this by the number of ways to choose 3 questions from the remaining 7. So we're going to choose from the 7 remaining questions 3. Okay, so this will work out to be equal to 5 times 7 choose 3 is 35, which equals 175. So there are 175 ways for a student to pick 4 from the first 5 questions to answer, and then 3 from the remaining 7. Notice again, they come up with 7 questions answered. Now for case B, what we want to do is pick 5 of the first 5. Okay, I'm going to type these answers since the pen is giving me this much trouble. It might be just a little quicker to type them. So in case B, the student would have picked 5 of the first 5. In other words, answered all 5 of the first questions. Again, the reason we want to do that is because there's 2 cases here. Either they answer 4 of the first 5 or all 5 of the first 5. So in case B, where they do answer all 5 of the first 5 questions, that means from the 5 questions, the first 5, they're choosing all 5, but they still need to answer 7 questions. So that means from questions 6 through 12, there's 7 questions left. They must choose 2 more questions to answer. Okay, and that'll give them a total of 7 questions answered. So 5 choose 5 is of course 1. 7 choose 2. We'll quickly answer that. Calculate that, and it's 21. Therefore, we have 21 ways of answering 7 questions where we select 5 from the first 5. So the total number of ways of answering at least 4 of the first 5 questions and answering 7 questions in total will be the sum of these 2. So it will be the total number will be 175 plus 21, which gives us 196. Okay, this is an example of picking how many subsets can you create from a set of items, and they're all distinct. So this is like the block question where all the blocks were different colors, and we were asking ourselves how many ways can we pick at least one block. This time the blocks are the toppings for our pita. So how many toppings do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all together. So what that means is the number of ways to dress our pita will be 2. So I'm going to get my 2 to the exponent 10, which is equal to 1024. Another way of seeing this is for the lettuce, like if I'm going to dress my pita, I can either have lettuce or not have lettuce. So in other words, that's 2 choices. For the cucumber, same thing. I can even have cucumbers or not have cucumbers on my pita. Same thing for the onions, tomatoes, green peppers, hot peppers, mushrooms, green olives, black olives, and pickles. Every topping I can either have it on my pita or not have it on my pita. So the number of ways I can dress my pita will be 2 times 2 times 2, because I have 2 choices for every topping. Either I have it or I don't. So 2 times itself 10 times, which is 1,024 ways to dress my pita. Now notice I don't subtract 1 here, because the question assumes that dressing your pita includes the fact that you might decide to have no toppings. Okay, so this 1024 includes the option of saying no to everything and just having a plain pita. So that's why the answer is 1024. Okay, I'm back to the pen. I'm going to see how long this thing lasts before I switch over to text. This one's pretty tricky. It combines almost a Venn diagram question with a combination question. So the first thing is I'm going to try to figure out how many students are in each set. So I'm going to be a little lazy here simply again because my pen has already died. So I'm going to skip over and go to text. So this will take me a little longer, so give me a second. Okay, folks, I apologize for that. The first thing is I had to figure out how many were in each set exclusively. So it says that there are 5 members of the golf team and 8 members of the volleyball team. So, and one of them is on both. So I drew my sets, and I should have labeled these, so I'll just see if I can do this quickly. This one is going to be my golf players, and these are my volleyball players here. So there is one person who's in both, so that person is in the middle in the overlap. Since there are 8 volleyball players, there are 7 people who only play volleyball. Since there are 5 golfers, there is one person who is also a volleyball player. There are 4 people who are only golfers. Okay, so now that helps me because now I can answer the question, how many ways could I create a committee of 4 with at least one member from each club? So the easiest way to do this is the indirect way. If you can have at least one member from each, then that means the one case or the 2 cases you can't have is having all golfers or all volleyball players. So I'm going to look at, first of all, the number of ways I can select 4 people from the group of 12. We call that without restriction. So that's 12 choose 4 or 495. Now from that, this represents every single selection of 4 players from the group of 12. That includes at least one from each club, but it also includes the condition we don't want to happen, which is either all golfers or all volleyball players. So how many ways can we choose 4 players that are all golfers? That'll be 4 choose 4, which is equal to 1. Now why isn't it 5 choose 4? Because this one person that is shared between the 2 would also be a volleyball player, and so that would be good. If they were selected, they fit the criteria of being from the volleyball team as well, so we are going to ignore them actually. We're just going to say from the 4 golfers, exclusive golfers, we're going to choose 4 players, and that is something we don't want to happen. We do not want to have only players from one team. Now to the volleyball scenario. If we choose all volleyball players, that'll be from the 7 volleyball players who play exclusively volleyball, we're going to choose 4, which equals 35. So 1 in 35 represent the number of ways we can select a committee where we have something happening that we don't want to see, which is all people from one team or the other. So we want to subtract those 2 cases from the overall total of 495. So 495 take away 1, take away 35 leaves us with 459. And this is the number of 4 people committees where there is at least one person from each club. Tricky question.